Hello, we are group number 27 and we will be presenting quinine. Jessica will present the disease malaria, which quinine is predominantly used to treat, as well as the general structure of quinine, and Arun will talk about how exactly quinine works. My name is Izabelle and I'll be discussing what other uses for quinine there are, as well as the negative effects of quinine treatment. Hope you enjoy our presentation.
When a female Anopheles mosquito infected with the Plasmodium parasite feeds on a human, the salivary glands of the mosquito transfer the parasite into the human's bloodstream. The parasite then multiplies in the host's red blood cells and causes the disease that we know as malaria. Although the disease is brought on by a tiny mosquito, malaria is able to impact essentially the whole body and cause serious pain and suffering. Malaria is still very common today in parts of South America, Asia, and Africa. However, in Africa, it is the most prominent, accounting for 90% of malaria's cases and deaths worldwide. Quinine was the first compound discovered to treat malaria and is still used today. Derivatives of quinine were also produced to fight the parasite like chloroquine, but the parasite was able to quickly develop drug resistance to these derivatives. Quinine has the chemical formula of C20H24N2O2 and is an alkaloid. An alkaloid is a naturally occurring compound produced by a plant that contains nitrogen and is able to have a physiological effect on humans. Quinine is an odorless but bitter-tasting compound that is often presented as a salt and is taken in the form of tablets.
So quinine was discovered in 1820 by French researchers Pierre-Joseph Pelletier and Joseph Caventou. It was first found in bark extract from a cinchona tree, which is native to Peru. It was later purified to form quinine through chemical synthesis. Quinine is used today as a standard treatment for malaria and was the first successful use of a chemical compound to treat infectious disease. So what is the mechanism of action for quinine? Well, believe it or not, this is not 100% known. However, through in vitro studies, it was found that quinine is used for its toxicity to the malaria pathogen Plasmodium falciparum by interfering with the parasite's ability to dissolve and metabolize hemoglobin. As seen from the picture to the right, the normal pathway involves hemoglobin being consumed by the parasite, forming ferroprotoporphyrin, which is a toxic heme. This is then converted to hemazoin by crystallization, which is a non-toxic compound, which allows for the consumption of hemoglobin by the parasite. What quinine is known to do is it's known to inhibit the formation of hemazoin in the heme detoxification pathway. This then facilitates the aggregation of the cytotoxic heme, which kills the parasite from within.
In most of your experiences, how often do you see someone be infected with malaria? Probably not at all. What other uses of quinine are there, you might ask? Quinine can be used to treat muscle cramps, specifically leg cramps. However, this other use of quinine is still in debate throughout the medical field. Many studies have shown that there really are no substantial results showing quinine's effective use to treat either the duration or intensity of muscle cramps. One pretty interesting thing to note is that the FDA banned over-the-counter use of quinine, as well as the marketing of quinine to treat leg cramps in the mid-1990s. Pretty serious, huh? For the FDA to ban a substance, there must have been good reason. Another thing to note is that there are many adverse side effects that comes with using quinine. These include headaches paired with chest pains, dizziness, unusual bruising, blood and urine, and hypoglycemia, just to name a few. All for a leg cramp? Definitely not worth. To put it simply, unless you have malaria, you should not be using quinine. Last but not least, we wanted to thank you all for watching, and we wish you all good luck on finals. Bye!